everybody. People are still awake, so I'm going to try and keep that going. I really would like to thank the Association for Glycogen Storage Diseases for inviting me today. What I was asked to speak on is the trial update for the Ultragenyx or DTX401 trial for glycogen storage disease type 1A. So I am going to disclose that I'm an investigator in this clinical trial, in the two clinical trials we're going to talk about under the sponsor of Ultragenyx Pharmaceutical. And I have taken pieces of Ultragenyx slides, previously published data, and questions from patients and families that were submitted to the sponsor. I am going to give you my own opinions, and I'll try and delineate kind of where this is data that's been presented, my interpretation of it. And then I have also served as a consultant to Beam Therapeutics. Okay. Oh, and I did want to mention here, again, I do not have everything that I'm presenting has been published or presented in some way, shape, or form prior to this. There was newer updates from some preliminary data from phase 3 that I'll include, but a lot of it will be kind of my interpretation and data that I'm hoping to see in the future. So my topics today, we had some really wonderful talks that nicely led into this. I am going to briefly, again, orient us with genes and genetic disease and some potential therapies. Again, some really beautiful summaries from Dr. Al-Ghabari and Dr. Coburl earlier today, so I will not go into it at length. I'm then going to talk about the studies that are going on with Ultragenyx DTX401. Specifically, there's a phase 1/2 study that's ongoing and further out, and there's some preliminary data for phase 3. I'm going to reorient us again, kind of what does that mean and how do we use the data from those two studies. And I'm actually going to present them a bit in parallel to link up the data. Hopefully that works well. And again, to highlight, we've heard about all sorts of incredible, hopeful things for the future with investigational products. This is still an investigational drug, and we do not have the database, all of the data yet based on these studies. And then talking about the future. Okay, so briefly, what is a gene? Many of you heard about this earlier today. Again, a gene is a small sequence within DNA that ultimately, moving down the line, gets transcribed into RNA and then ultimately translated into protein. And the protein is the part that has the action in the body to potentially work well, or if there is an abnormality, cause the disease. Again, today I'm only talking about clinical trials for GSD type 1A, which is a mutation in the glucose-6-phosphatase gene. So to use this example again, the protein, or glucose-6-phosphatase, is very important, is essential in releasing from both stored glycogen and newly formed glucose-6-phosphate from gluconeogenesis. And so when there are abnormalities in this gene, it causes GSD type 1A. And we'll talk a little bit, again, I'm not going to give a lot of background, but we're going to come back to it at the end, that there is acutely life-threatening hypoglycemia and acidosis, but there's also severe long-term associated complications. To briefly comment on the standard of care, it is currently uncooked cornstarch in diet, and as somebody who doesn't feel like the 1980s were all that long ago, really some of these advances are relatively recent. Okay, I ran through that. I'm going to run through this a little bit quickly as well. Again, other talks have commented on it. I'm going to just put this into the context as to what these studies we're looking at versus some of the other investigational products that are currently being studied or we're anticipating studies in the future. So the Ultragenyx product, or DTX401, does this allow me to? Maybe not. Also, the phase 3 was called the glucogene study, and that it is currently has 2 ongoing trials, a phase 1/2 trial that's depending on when you started treatment, which we'll talk about, is approximately 3 to 5 years. And phase 3 enrollment is complete, and all patients have now been treated with investigational product. These pictures here, and I'll come back to the one responding specifically for this trial, is that not to belabor this, but that this product is in an AAV8, which is an adenoviral vector, and has a stretch of corrected DNA within it. This was beautifully talked about by Dr. Coburl earlier today, where essentially how I describe it is, sorry, there's something blocking my screen. that essentially drops this package off in the nucleus. So it is not putting DNA into your own DNA, into your own genome. It is dropping off this package of DNA that the body can then use its own mechanisms to create the corrected protein. This is not permanent, and we'll come back to that in a bit. RNA therapy is not a gene therapy, but it's kind of going along that pathway between gene, RNA, and protein, and there is an ongoing trial right now with Moderna Therapeutics that I know that there was a presentation about last night. And then future, we've talked about gene editing in a number of different ways. Our anticipation and understanding is that Beam Therapeutics is going to have an open study in the near future looking specifically at nucleotide editing. Interesting. There we go. Okay, so this picture comes back again because, again, this represents what type of study we're talking about. So the investigational product is DTX401. What I have up on the screen right now are some features of this product that actually are not specific to DTX401 to start with. I mentioned this is effectively an empty virus that you put a stretch of DNA in, and it has specific features that direct it towards the liver. Okay? This is a very commonly used vector in gene therapy, and it's commonly used because it's been well defined from a safety, efficacy standpoint, and particularly for a target organ such as the liver, highlighted before that this product is targeting the liver, not the kidney or other organs, that AAV8 works quite well in this regard. The rest of it is a mixed bag. Again, there's always positives and negatives. It is not integrating, so again, it's dropping off a packet of DNA, is not inserting it within the person's DNA. It provides a corrected gene from this DNA, and we know that this will last a long time, but that as the liver grows, these cells divide, holding these packets of DNA within them, and so the effect is anticipated to get diluted over time. So for all of these types, especially when we're talking about liver basis, we don't have specifics as to how long this treatment will last. It's largely anticipated to be on the order of years, but not lifelong. This highlights some of the limitations. Duration of effect. Nicely, I'm following Dr. Young-Muckley's talking about readministration due to autoimmunity. This is something that plagues AAV8 outside of GSD studies, kind of how, if it only is on the order of years and not lifetime, how do we redose? And that there really is a degree of effect. This is a modified, again, empty adenoviral vector, but still can cause liver inflammation and injury. And so finding that balance to get enough of that DNA packet dropped off versus minimizing the inflammation and injury is very important. I'll say specifically to DTX401 that you can see, and again, this is provided by Ultragenyx, this figure on the bottom, is that it is working under what's called the native promoter. So in somebody whose body has the correct form of G6PC, you're gonna have, your body is able to respond to features such as insulin and glucagon and steroids in the body and appropriately make that protein in response and have the protein appropriately respond to the environment that it's in. And so in this situation, not in all situations of gene therapy, that this promoter, again, that helps regulate the gene itself is kind of the normal human version. Okay. So briefly, I mentioned I'm talking about a phase 1/2 study and a phase 3 study, and you're gonna see me break it up. This is just a bit of a timeline to show you what is the process. We've seen lots of beautiful things on what, from a clinical research perspective, we refer to as preclinical, that is oversimplifying, but that is the tremendous amount of work that goes into cell research, animal research. We've seen different models, mice and dogs. That all in this talk kind of falls under this preclinical. Once you have good evidence in animal models, that's when you start moving into human work. So that is phase 1 and phase 2. And I have here that phase 1 is largely focused on safety. Again, what are the side effects that you have from these treatments? Phase 2 is in a small group, are we seeing any positive benefits of this therapy? And then ultimately, if phase 1 and phase 2 studies, in this study they are combined, which is very common in the rare disease research populations, You go into phase 3, which the goal is to have a much larger population and have additional controls to really see what are the benefits and what are the negatives to the whole population. Ultimately, and again, I highlighted what I'm talking about, is not yet approved as a therapeutic. Ultimately, if there is enough evidence from these prior studies, that is when a new drug application is placed to see if it can be used outside of research. So again, I'm going to do this in parallel. It's the first time I've presented like this, so here's hoping. So phase 1/2 I talked about in phase 3. So phase 1/2 is an open label trial that has dose escalation and steroid optimization. I'm going to talk about that on the next slide, and it really is that there's a lot done in a small number of people, and so you have to interpret it in that way. Again, there's key eligibility. You have to have GSD type 1A. You have to have a history of hypoglycemia, but there's a number of features for all clinical studies referred to as inclusion and exclusion criteria. There was a number of questions from kind of generalized populations for people with GSD that really kind of talking about screen failure was a big concern. So about 26 individuals were interested potentially in participating in this initial trial. 12 ultimately were able to be enrolled. So why were they not able to be enrolled? Liver inflammation with AST, ALT elevation was the most common feature. Again, when you're talking about a study, you want a population that is as clear as possible to see the effects. In addition, you want to make sure there's safety, and so individuals who already had a degree of inflammation were eliminated. Liver adenomas, again, from a safety perspective, greater than 5 centimeters, were not participating in the phase 1/2 study or the phase 3. And then ultimately, again, a lot of Dr. Young-Uk Lee's talked about kind of AAV8 and how do you overcome some of these neutralizing antibodies if you have them just from the environment or from prior treatment. Again, this is an issue that is a problem for all types of studies like this, but approximately 5 out of the 26 were eliminated, so that's about 20%. Phase 3, I know this is a complicated small diagram, but the most important features of phase 3 is that it was approximately 50 patients divided into 2 groups at the beginning. At the beginning, everybody got an infusion of the investigational product, DTX401, and at the beginning, you got either a placebo, which means that it was identical in every way, shape, or form, so that both the patient and the doctors taking care of that patient were not aware that they were not actually getting the therapeutic drug trial product, versus the other half did get the investigational product. This then crossed over to a year. So what I'm going to be presenting is the first 48 weeks. So again, in approximately 50-person trial, 25 people actually got the medication in what I'm going to be presenting, and 25 did not. This trial is still ongoing. So at this point today, everybody has now had 2 infusions. And so the people who did not get the investigational product at the beginning have now gotten it a year later. And again, this allows us to compare these populations, right? We want to know if a drug is better than what we're currently doing and what risks there are to individuals who got the treatment versus those who did not. So this is for phase 1/2, and then I'll flip back to phase 3. So phase 1/2 was only 12 patients. And you can actually see them listed here with their genotypes, what their baseline cornstarch was, and the baseline time to hypoglycemia. We'll talk at some of the data that we looked at in all of these groups. And I will say again, phase 1/2, what were its goals? Safety, and if we could see some early benefits. But a lot of the focus was, what is the best way to give this product to individuals? And so there were actually 4 groups starting at different time points, starting July 2018 were when the first individuals were treated, starting January 2019 was the second, and ultimately the last group was treated as recently as October 2020, pardon me. And so I'm gonna present the data up to March 2024, just because that is the most recent time point that we have data for, but to highlight that they got different doses, 2 × 10⁴ for cohort 1, increasing the dose of, again, this is vector, including the DNA product, for the final 3 cohorts. And then steroids. I mentioned that inflammation. When you give somebody a vector containing DNA, the body's going to respond to things that are foreign. And so steroids are very commonly used in these type of studies. There are some newer methods, but these were treatments to try and suppress that inflammation while maximizing the ability to deliver the investigational product. And so each one of these groups had a different treatment protocol. And I'm happy to answer more, but that has been presented. So to go back to that initial phase 1 versus phase 3, you guys are gonna get used to this hand motion, that in phase 3, they use that final dose, 6 times 10 to the 12th, pardon me, I misspoke earlier, 6 times 10 to the 12th, and then did steroids right off the bat, trying to get ahead of any potential inflammation, again, to maximize the liver being able to retain this product. And then I mentioned already at this time, everybody has gotten the investigational product. But highlighting some of the data we do not yet have is I do not have any of the data on sex, age, what diseases did people have at baseline, and genotype. So we talked about different genes that make up the population of people who have GSD1A. This has all been collected, and this is why a bigger number study is incredibly important. And I do not, though, have that data at this time. Okay, so to go back to this rubric, phase 1, 2, and 3 really had the same key study assessments. Truly, the 2 major goals are, how does this treatment affect cornstarch dose and frequency? If it changes cornstarch dose and frequency, does it affect blood sugar values? How long can somebody safely fast? And so that's referred to as TTH, or time to hypoglycemia, in a controlled fasting challenge. How does this change an individual's nutrition, or are there special things that we need to be prepared to do to affect somebody's nutrition, as well as safety and patient experience? So let's talk about changes in cornstarch seen in both studies. So if any of you heard my talk last year, I largely presented this figure. So what this figure is, there we go. It's tiny, but it's there. Okay, so what this figure shows is from the baseline before therapy in phase 1, 2, again, there were 4 different groups, 12 different patients. Each one of these lines represents an individual patient. This is how much cornstarch they had at baseline, and this is the percent change. Again, so if your cornstarch at baseline, I'm not gonna do this math in my head, was 300 grams, if you dropped by 60, that is 80%, this is where your point would be. So what this demonstrates in phase 1, 2, up to the last visit for these patients by March 2024, so that's 3 to 5 years, depending on the group, there was an average of a 70% decrease by year 1. So this is all the way here at 52 weeks, but this persisted for this 3 to 5 year span. I'm gonna highlight and mention again later that you notice there's a lot of variability in the patients. What caused that variability? 12 patient studies can't tell us that. This is a frequency, and some of these I'm gonna go through rather quickly, but I use this again to highlight the variability. Each one of these areas is a single patient, and each full graph is a single phase. Again, 4 phases, 12 patients. You'll notice from a baseline how much the number of times somebody took cornstarch can decrease drastically in some patients, and in others largely stays the same, okay? And some dropping and increasing again. Again, this is up to the most recent time point for the patient, so there's a fair bit of variability, but the overall trend, as I showed you in the last slide, is a decrease. Okay, decreasing somebody's cornstarch is not the whole story, and we'll come back to that again, but the first thing you have to think about, that's great, if you decrease cornstarch, you have to make sure that the blood sugar remains stable for that. And so the development of sensors and increasing accuracy did not allow sensors really to be used in the early parts of this study, but in the last 2 groups, so again, this is 6 patients, the last 2 groups, sensors were used, blood glucose sensors, as individuals drop their cornstarch. So as you can see here, the blue lines represent a decrease in the cornstarch dose, and what you want to see is these green bars remaining largely stable for blood sugar within a safe range, And you want to see kind of the lower bars for a blood sugar less than these purple bars at the bottom, less than 60, not increasing. Because if you saw the cornstarch drop and the hypoglycemia increase, that's not telling you anything very helpful for the individual. So how was this dealt with in the phase 3 study? Again, phase 3. So daily cornstarch decreased at approximately 41% at week 48. So again, we're almost comparing a year to a year. I will say in phase 1, tremendous variability, approximately 70% decrease. Phase 3, we actually don't know very much about the variability. So it was only these very kind of high level, as companies often use the term, but I'd say very kind of generalized results, where we can see here, I'm gonna put my reading glasses on to do this, so that we can see that individuals who got the placebo, again, this is comparing approximately 25 people who did not get the drug yet to 25 people, and again, the specific numbers are down here, to 25 people who did. What we see is a drop in cornstarch in comparison, so an incredibly important comparison, especially that both the patients and the doctors were blinded to knowing whether that patient got treatment. We do see decreases in cornstarch that were initially evident on this graph by 24 weeks and continued to drop by approximately a year at 48. I'm going to get into a little bit more of the statistics. I'm not a statistician, but I think some of them are important to acknowledge when you're interpreting the data a little bit more in the next few slides. But what I'd say is this is very significant. When you look at the numbers alone, again, what does it mean to the patient? This doesn't answer. But when you look at the numbers alone, this clearly has a significant difference. And when you look at the data in a different way, that, right, this is comparing to people with GSD1A who did not get this treatment. Those who had a greater than 30% reduction was about almost 70% for those who were treated, and 13% had a greater than 30% reduction. So you're comparing this against each other. And then for those who had a greater than 50%, generally we did not see this in the placebo-treated group. Only about 4% of them had a reduction of greater than 50%, and 37% in the treated. Okay. Oh, and I will comment, because I'll mention it here again. I have to admit, as not a statistician, I also had to pause and say, what does LS, so least squares, mean? Again, this highlights that there's a lot of variability to this population, and so they're using statistical methods that are appropriate to a very variable population, but I think, again, highlights that there's some variation that we don't have the details on yet. What is the frequency of cornstarch doses? When I talk to my patients, it's honestly not so much the volume, it is how many times a day you need to take cornstarch. Again, that is anecdote from me, but in talking to families, and especially adults, that is often the biggest issue. So I will say, I added the blue box here because I think this is some of the most important when we look at it. So appropriately, the baseline average between the placebo group for total doses of cornstarch a day is very similar to what the treatment group, again, before they got treatment, so everybody was taking about 5.1 to 5.8 cornstarch doses a day. And when you see the decrease, those on the DTX401 group, on average, had a decrease of approximately 1 dose a day, okay, so minus 1.1. Overnight, that change, again, from a very similar baseline of taking approximately 1.7 to 1.8 doses at baseline before treatment. Those who were in the treated group dropped that by minus 0.4. Those in the untreated, in the placebo group, raised it by 0.3. So again, when you look at this, there is a decrease in frequency of cornstarch doses. This is a generalized response. I will say I'm highlighting the red box. They highlighted the red box initially. This is statistically significant. For the physicians in the room, we often say things are statistically significant. You then have to put on a different hat and think about kind of the clinical significance. So I'm not saying that it's not important. It is very important to make sure that you clearly have evidence of a change, but I would say, I think sometimes it depends on the person. But decreasing by an average of a half dose, that could mean some individuals went down from their 2 doses a night to 1 dose, which may be very significant, but we need some more information. Glucose control, again, I showed that for phase 1 too. That was the graph where we saw cornstarch come down and nicely people stayed within. I'd say it's a little less clear from the data that's been presented. I'll highlight briefly that you do see trends where there was an increase in blood sugars less than 70 for those in the treated group compared to those in the non-treated in the placebo group. But severe hypoglycemia is very similar, and the statistical testing they used is non-inferiority. So this is somewhere where you predict what the change will be, and then you're comparing these two groups. So I'd say more definitely needs to be seen, because having a cornstarch reduction with some hypoglycemia, increase in hypoglycemia, is something that we need to look at very carefully. So again, very statistically significant, may truly be truly significant, and I am reassured that we really don't see additional severe hypoglycemia as cornstarch was reduced. And I'll highlight some of the other things. Again, as a physician, I'm looking forward to more data as it comes out. Again, this is preliminary from phase 3, so fully acknowledged by the sponsor and anybody involved that there is a lot more data to come. So what are my conclusions and changes to cornstarch? Is that both studies, again, I'm lumping them together, showed a significant decrease of cornstarch of 40 to 70%. We're gonna talk about nutrition. I don't minimize that. Like, there is a lot of nutrition of other sources that could fit into a cornstarch decrease of 40 to 70%. And largely the data is supportive that even with this significant decrease, the blood glucose was stable, particularly kept into a safe range. Again, the change of frequency of daytime doses by approximately decrease of 1 dose, and nighttime by approximately 0.4 doses. And then additional information is still needed. Again, when you drop cornstarch doses, one, you want to make sure you're not making people hypoglycemic, but I think it was a very nice summary this morning talking about you also need to think about the long term. So a lot of the things that I'm looking forward to see in the future from this data is kind of with the cornstarch doses, what is the metabolic control that we see measured by triglycerides, uric acid, and lactic acid? I'll comment kind of long-term for these studies are very hard. Think of how long it took to get here. There is still a lot more information in the future. So that doesn't mean that that's a problem. That is just reality, that there's a lot more to learn. And also kind of the nutritional changes. I'll have to go a little bit faster because I've taken my time. So let's talk about fasting tolerance, time to hypoglycemia. Phase 1-2, on average, there was an increase in ability to fast of approximately 4 hours. Again, as a physician who takes care of patients with GSD, that is, I really would like people to be able to sleep safely through the night and have a longer period of time. Again, when they look at the comparison, I'd say one of the things to highlight is we highlighted a year, and the phase 3 data is only presented at a year. If you notice that baseline time to fasting, and again, time to hypoglycemia depending on the stage of the study, was either less than 54 milligrams per deciliter or less than 60. It was 3.4 hours at baseline. By approximately a year, increased by 5 to 5.2 hours. And then at last visit, so that's 3 to 5 years after treatment, went up to 7.5. So I'd say what I take away from that is that the phase 3 data, we do not even know kind of beyond a year. So there's additional information to get from that perspective. And again, those treated the earliest, so looking at cohort 1, which at the time of this were all approximately 5 years out from treatment, the mean increase was 8.1 hours. Still a lot of variability, 4.1 to 11.2, but really a considerable increase. I actually did not have this slide in initially. I was going to take it out. I'm more, again, just using this to show the variability. This is kind of over the entire length of the study up until the point, phase 1-2, that I can present. And you see some individuals really very striking increase, and then some individuals not a significant difference over time. So again, I'm highlighting variability and difficulties, why there is a phase 3 with much bigger groups and more information collected. So time to hypoglycemia per gram, again, on a very kind of generalized high level, approximately an increase of 5 times. Now, how are they demonstrating that? What they are showing, because this is a complicated way to show it, but I do actually agree, I believe it is probably the best way, is that everybody started with a cornstarch dose. These fasting studies, as individuals, right? I said the average decrease in cornstarch was 40 to 70%, depending on the study. As you're decreasing people's cornstarch, you're decreasing their cornstarch in the study. And so at lower cornstarch levels, individuals were still fasting longer. Okay, so this is presented as time to hypoglycemia in minutes per gram of cornstarch. So this was a way to try and interpret it with those two moving features. And again, at 48 weeks, approximately a year, there was an increase of approximately 5 times as many minutes per gram of cornstarch. That one I had to go through a few times for myself. So what are some of my conclusions? Both studies do demonstrate an average increase in time to hypoglycemia as a marker for fasting tolerance. A lot of variability in phase 1-2, and we do not yet have that data in phase 3, and I'm looking forward to that. The phase 3 data, as it's a larger group and placebo-controlled, that is a much stronger way of looking at this. Again, especially with the variability, you want to have that treated population versus the untreated. And so again, are there factors that affect how well somebody can fast? I just came from a beautiful SGLT2 talk and talking about treating pediatrics versus adults. What does age have to do with it? What does genotype have to do with it? And some of the data that I sped past is something that as a group people are looking at more, kind of, are there other systems in the body that are taking time to adapt, like insulin and steroids? This talk is too limited to go into that today. From a clinical perspective, goal of time to hypoglycemia is an increase of sleeping safety through the night. Again, as a physician, that is my view of it. I'd say I like this morning kind of the highlight. Not only in these type of studies you need to compare to the placebo, which is lovely, but you need to compare to the current standard of care. Again, and I'll highlight kind of glycosade, how long that lets you fast versus an interventional study like this. Again, these are the things that if and when this becomes an offered treatment that individuals should be discussing with their doctors. Okay, nutrition. So really, there's only data for phase 1-2. I've presented this previously. Again, to remind you, this is baseline to last visit. Mean total calories, decreased from 2,300 to 2,000. That is a significant decrease. Again, individuals with GSD1A struggle and are more prone to obesity, in part because your body is dependent on these added cornstarch calories. So that is not an insignificant decrease. And I will comment, kind of linking it to this weight decrease. Nicely, as cornstarch was decreased over this time, we did not see weight gain, which would be potential if cornstarch was replaced with other means to maintain blood sugar. The mean calories from cornstarch decreased significantly, almost 800 kilocalories. So again, average adult diet, 1,800 calories. This study decreased the cornstarch calories by almost 800. And the mean total carbohydrate from cornstarch, when you're talking gram by gram, if you're drinking it, went from an average of 277 grams per day to 78 grams per day. Again, variability. I know I've said that like 300 times, so I apologize, but by averages looks quite impressive. The macronutrient distribution, again, you don't want to take cornstarch carbs and replace them with other carbs. That there was really beautiful data in the late 70s, early 80s that really highlighted the benefits of cornstarch over just a high carbohydrate diet that preceded it. And that nicely, we did not see kind of that nutritional carbohydrates increase in response to this. Safety and adverse events. There's a lot of words on these two slides that I'm going to give you. That is not to say, and then I'm going to do it relatively quick, that this is not important. This is incredibly important. But, so all of these studies need to collect data as to adverse events. And what I'd say is this is phase 1-2, and there is very minimal out there right now for phase 3, which again, for a complex disease that has known underlying medical problems, having the placebo group is essential to compare. But I will say that there was no severe dose-limiting toxicities. Nobody was discontinued from the phase 1-2 study due to a serious event, and nobody died. The frequently reported issues were gastroenteritis and hypoglycemia. That doesn't mean that the drug, the investigational product, was responsible, and again, that's where placebo groups help a lot. Most of them were kind of a moderate grade event. There was a severe life-threatening event in one participant. And kind of what are the most common when I talk about adverse events? I mentioned already that liver inflammation shown by AST/ALT was everybody. Phase 3 highlighted that this improved back to the individual's baseline or within the normal range. Back to phase 2, about a third of patients had hypertriglyceridemia over the study. About a quarter had high blood sugars, hyperglycemia, and about a quarter reported headaches. So these are the most common reports. Again, we need to see it compared to placebo to see the differences over time. Some of the very specific interest, again, that there's a lot of experience using AAV8 and other similar technologies. No participants in phase 1/2 experienced infusion-related reactions, including hypersensitivity. I talked about the transaminases and that known risks with AAV8 therapy, such as effects on dorsal root ganglion toxicity, this is a part of the neurologic system, or clotting was seen. Phase 3, very little has been analyzed to date. Again, this is very preliminary, and this study is only about a third of its 3-year course right now. Again, saw elevations in AST/ALT of 76% compared to placebo of 12%. I will highlight that I used the terminology that after implementation of a risk minimizing measures, including slow stage ramp of infusion, there were no infusion reactions. It is a known risk for treatments of this type to have a risk of an inflammation reaction to the viral vector that you're putting into somebody's body. So this is something that this study and every other one, it was and is prepared for, but they note that there was a change in protocol to further minimize this. There again, there was no kind of toxicity that we see at 1 year of time to that neurologic DRG risk or blood clotting. And again, we do not know all of the long-term safety. This study is out 1 year, the other study is 3 to 5, which is long-term. And I'll comment the future by FDA regulations, these patients are gonna be followed for up to 10 years. Patient experience. And I am already at the end, so I'm gonna go through this quickly, although it is not unimportant. Both phases looked at patient experience. Again, were there positive experiences participating in this trial and with the treatment from your whole perspective of your life? Only phase 1/2 has data that's been reported. Again, when you look at different measures, these are studies that, these are surveys that people are given. 9 participants, when they had data at week 52, this wasn't started at the outset, felt that their GSD1A was moderately or much improved. Again, they did not have placebo. They do not have anything to compare it to beyond their own experience. And then most patients, when they reported improvements, they were primarily over time in sugar stability, energy, anxiety and tiredness, so improvements in any anxiety or fatigue symptoms. There were some negative reports in another survey that most commonly was stated as difficulty with change in routine, school or work, and an increase in headaches and frustration. Again, very tiny numbers. We're talking these were surveys of 5 to 7 people in phase 1/2. These surveys were continued in phase 3, and I'm very interested in kind of seeing that, especially that the participants were blinded. So finally, in summary, that I'm presenting today the additional information based on phase 1/2. Again, generally for these clinical trials, you need to kind of have all of the data together and do big publications. Phase 1/2 is anticipated to have a publication coming out shortly, but most of that data has been presented, and I represented some of it here. This is very preliminary data for phase 3, again, this has not been officially published, but released by the sponsor a few weeks ago. Both studies demonstrate a decrease in cornstarch. That is very clear and have some evidence of associated glucose stability/safety. And nicely, phase 1/2, I really like that nutritional data, that we do not see a weight increase. We do not see an increase in other nutritional forms of carbohydrates, which is reassuring, but I'm looking forward to the data in phase 3, especially comparing to the placebo group. There are some changes in frequency of cornstarch. I think that's a little bit harder when you have to think about it on a more individual level. And I am very interested, again, in getting more information as to that variability, which is what the power of a larger study like phase 3 has. There is evidence of a positive impact to time of hypoglycemia. In phase 1-2, there was a lot of variability. And I forgot to highlight, they're showing a small standard deviation in phase 3 for kind of the variability seen. But I think, again, some of the statistical needs kind of highlight that there is likely some variability, and knowing if we're able to correlate it with anything specific about those patients will be important. And I'm very glad to say the study has been collecting information on patient experience because, again, a lot of it is numbers. Numbers are incredibly important in the ability to compare these two groups, but kind of individuals' experience, I think, needs to be shared as well. From a safety perspective, really, we don't have anything from phase 3, I'd say. But virtually everybody has elevations in transaminases. Some of the common effects from phase 1-2 is elevated triglycerides, blood sugar, and headaches. There was rare, very severe adverse events and no deaths. I highlight that phase 3 protocol, again, an anticipated risk was infusion reactions, and it is commented that there was a change. So I'm gonna say secondary conclusions. So I tried to do this talk from the perspective of how do I digest this if I was a patient or a family member, and also how will I digest this and explain this to my patients in the future if this was a treatment that was being considered. So truly, I'd say some of the big unanswered questions that I'm looking forward to more data from the phase 3 that will just take time is that really, I mean, we want safety now, but what is the long-term effects? GSD 1A has severe effects to the liver, so liver damage, adenomas, carcinoma, but as well as to the kidneys. And again, this treatment, nor any of the others right now that are under investigation, are addressing directly the kidney, and I'll say there is scientific reasons for that. It's not that people don't recognize it. I've explained to some of my patients, liver is low-hanging fruit. The liver is a much easier organ to get gene therapy or other related therapies into. And so, but how does it affect your kidney disease long-term? And so there is follow-up for 10 years, and I realize a lot of people say, well, what does that mean for me now? Again, I'm hoping for more data in the next 2 years. What are the predictive markers of this metabolic control? Again, waiting 10 years to see the effects on kidney is not generally realistic when we think about it, but do we have additional information that will be forthcoming from phase 3, looking at things like triglycerides, uric acid, imaging of the liver and kidneys that might give us additional information as to potential risks or improvements or declines in some of these risks in the future? Who is this treatment best for? We talked a little bit earlier today about some of the more targeted treatments, some of the gene therapy treatments that are necessarily targeted to specific mutations. Does this treatment as well benefit individuals in some categories more than others? And then nutritional changes. I will say a fair number of my patients say, I still love this. I will quote somebody. He said, well, but will I be able to sit down and eat a large piece of chocolate cake for my next birthday? That was really one of the questions as he was considering participating in this study. And I'd say, I think that's a very fair question that I will be honest, I don't anticipate having all those answers at the end of these studies, but I'm looking forward to any additional information. And I'm gonna highlight, this is not just the Ultragenyx talk, that oh my goodness, it is so exciting to be here and to have so much hope and feeling like we're on the precipice for so many different treatments and so many different treatment options. But I will say, these are not cures, and that's something I remind my patients about. That doesn't mean that you shouldn't be excited, and that doesn't mean that they don't have the potential for really life-changing impacts, but I think it gets very confusing when we talk about genes and gene editing, that really it can be a difficult thing to wrap your mind around when multiple parents of patients have said, I've been waiting for this my whole life. And adult patients, I've been waiting for this my whole life, and I understand that. But we do have to recognize these are treatments with risks and benefits and not necessarily a cure. So still be excited. I am still excited. I'm excited to hopefully be able to present or have somebody present more phase 3 data that, again, that it's a bigger group, it has a placebo. I think will answer a lot more of these questions, but we're not there yet. I will acknowledge, I think I do not have an updated list for Ultragenyx here, but that's okay because the most important thank you is to all the patients and families who are participating or supporting research in many ways, shapes, or forms. Again, none of this work could be done for the community as a whole without those individuals who are really kind of giving them themselves and their time for research in novel therapeutics. I am saying that like the individuals who participated, the individuals from the clinical end, from the physician, from the research end, from multiple sites around the world, and particularly from the phase 3 sites, more than I believe it is 20 sites around the world that are participating and helping this research. Sorry to go over. I don't know if I have time for questions, but I'm certainly happy to talk otherwise as well. Thank you.
We probably have time for just like 1, 2 questions. Yeah.
Okay. I'm happy to answer any questions that individuals have. Oh, there we go.
Rebecca, a terrific
Yes.
talk. I just had one question.
Yes.
In your phase 3 study, the double blind,
Correct.
in the treatment group, you said 13 out of 19 showed a response and the remaining did not. Did you look into what happened there? What was the reason there?
Showed response. Wait, let me make sure. 13 out of 19. I think you're referring to.
Yeah, and whilst you're looking that up, have you looked at uric acid, triglycerides, cholesterol, etc.? Because it's wonderful to be able to reduce the cornstarch, but really would like to know what are the other biochemical parameters. And the second question is, how much comfort is there in someone to sleep at night? Because you still show some of them in the phase 3 study, it was non-inferior. So what does that mean? Do they still have to be bound to a CGM? I know these are outstanding, but I think I'm the patient voice here.
Dr. Kishnani,
Yeah.
beautiful, beautiful questions, very appropriate. I want to make sure I'm going through the list of what you asked. So first of all, it was, so I believe you're referring to kind of the 13 out of 19. Okay, 13 out of 19. So was that kind of breaking down the data a little bit? So what percentage of individuals saw the biggest decrease in cornstarch? So 13 out of 19 had a greater than 30% decrease in cornstarch. Again, trying to break that apart, is this just kind of averaged across? Did everybody have like let's see. Did everybody have a decrease of 30%, or did half the people have a decrease in 60% and the other half of the people have a decrease in 0? So it's kind of getting to how big an affect the largest group of people. So it wasn't that it only had an effect in 13 out of 19 patients. It was that there was a significant difference between the patients who were able to reduce their cornstarch to the greatest extent in those who were treated than those who had placebo. I know your final question. I might be missing the middle one. So your final question, go ahead.
But my point is, if you've lessened your cornstarch by less than 30%, is that really, I mean, have you gone more into looking why? And the ones where it was more than 30%, how were they when they started out? Was there room for metabolic management, to reduce it? Even before they started the trial. I'm just being devil's advocate here, just to be sure that I understand the data
and
here.
I appreciate it, and I think we all have to look at these treatments. It's not kind of a negative positive. You have to look at them. So my answer is, I think that goes to, the clinical significance. It's really wonderful when we have a numerical difference, but for me personally, how much does it mean for me personally? I'm giving an example, like taking 5 doses daytime versus 4 doses daytime. So it really is kind of seeing it. So I think Dr. Kishnani is appropriately kind of highlighting that. I do not have the answer, but I will highlight on the flip side that this is at 1 year, and it's only effectively showing approximately the response of 25 people versus the whole 50, and that we know in phase 1/2 that we continued to see changes in this, even when they compared the 1 year, the 52, to kind of 70 plus weeks, there were progressive changes. So my first answer is, I agree with you. You have to take that with a grain of salt, and numbers are great, but what does that mean to an individual in reality? On the flip side, I do think that there's more information to come from this, and that we do know that there can be some progressive benefits. to go back to, I think, your next very important point that I highlighted somewhat is, I am all for a treatment that helps with the here and now, and I happen to be a pediatric doctor by background, but the goal is for these treatments to kind of benefit somebody's life for decades into the future. And so that we will not have that final answer, but hoping to have more of those answers, such as triglycerides response, uric acid response, kidney response. So the data that's been that I've presented that's been published to date is the triglycerides, that a third of patients had high triglycerides. What does that mean? I will say research that came out of Duke originally really was able to link triglycerides to ultimate metabolic control. That is, I'd say, a very big area that I really am hoping, especially from the placebo versus treatment arms to see. I will say a lot of patients, I think I'm allowed to say this, a lot of patients in the beginning are like, I'm gonna know whether I got the treatment or the placebo, no problem. I will tell you, that was not very easy to know as a person working, and still hasn't even been released to patients or providers to know when they got the treatment. So I'd say having that placebo group is actually very important. And so to even kind of say it more specifically, I think a lot of people make assumptions and change how they're eating and change how they're taking care of themselves, and they don't know what treatment they got, whether it was placebo or not. So I really do think to answer those questions, we're gonna need to see the placebo-controlled data comparing those outcomes. There might have been a third question in the middle of that I missed. I apologize.
Okay, I think that's all we have.
Sorry,
Is it
I'm happy to go and talk.
Okay. Yeah.
Hello.
Hi.
So you said on phase 1/2 that there was one life-threatening like incident that happened. What do you define as life-threatening? Because like hypoglycemia is like kind of life-threatening. So what like made that like distinction between that was the only one that was life-threatening?
That's a very good question. I will say a lot of these come from definitions for clinical trials as a whole, and it then ultimately was the responsibility of the site investigator, so the site physician, to decide. So the answer is that's in part kind of standardized and in part otherwise. I agree, hypoglycemia is life-threatening, acidosis is life-threatening, vomiting for somebody with GSD1A can be life-threatening, and so it's kind of grading to the most severe. I will say I can't share the specifics of that individual and how it was more severe. I realize I went through the safety data very quickly. I will say, particularly for all chronic severe diseases, this again is a reason why we need placebo-controlled studies, because relating what happened because of a treatment versus what just happened as the course of a study also played into it. And so the physicians who are involved at sites give those answers to the best of their ability, but ultimately we need to see 50 people who did not have the treatment compared to 50 people who did, and say, how frequently did somebody have hypoglycemia? How frequently did somebody have a severe gastrointestinal illness? So I'm not minimizing the severity of them.
So do you think, like because of that, do you also back up the study saying there was only one life-threatening incident, or do you think there's maybe more?
So I'm trying to think of the best way to answer that. So my answer is, and I'm highlighting, so they highlight that there was grade 2s and grade 3s. I'm trying to think of how to best answer this question. I do agree, like I do agree with the data that I presented in the way that it was scored. I'm not disagreeing that there are other things that can progress to life-threatening with hypoglycemia. Part of the criteria is that it was severe enough to require hospitalization and higher levels of care is one of the criteria for a grade 4, to give that example. Does not mean that grade 3s could not have progressed. So I guess my answer is, I do agree with the definitions as a standardized way that clinical trials, but I also agree that this is a very severe disease, and other individuals who got grades 2 and 3, potentially, if they weren't addressed quickly, were life-threatening. I don't know if that best answers your question.
Okay, thank you.
Okay. Sorry to run over into the next speaker, who I'm very excited to hear from as well. I'm happy to talk to anybody else with additional questions.
Thank you so much.
No problem.